Hi everyone, I'm Madam Zarina. We are from Group 9 and today we would like to present the group assignment which the topic is the structure and function of Fire Weather Index FWI system. I'm Shaw Tong En and the metric number is 279874. First of all, I would like to present the background of study. Forest fires belong to the category of nature climatological hazards. Forest fires, also known as wildfires, is a significant environmental problem that threatens forest preservation, cause economic and ecological destruction, and cause human misery. Therefore, the related authorities such as Malaysian Meteorological Department need to predict the forest fires period to prevent something more serious happen in future. We can use the meteorological data to get the index from this FWI system. For instance, weather data is sent for temperature, humidity, wind, and rain. It means that weather data is a kind of weather observation. Therefore, we need use it on the calculation of FWI systems such as Fine Film Moisture Cord (FFMC), Dove Moisture Cord (DMC), Drought Cord (DC), and Initial Spread Index (ISI). By using this data, we can predict the forest fires. It's hoped that at the end of the study, we can conclude the Fire Weather Index FWI system is functional and realistic for environmental purpose. Secondly, I would like to present the objective of the study. We have three objectives in this research. First, to investigate the time record when collecting data. Second, to observe the weather data collected by weather observations. Third, to identify index data recorded of Fire Weather Index FWI system by month. So now I would like to pass to next presenter to present his part.
Good afternoon to Doctor and friends. My name is Liu Kok Yang and my metric number is 277134. I'm from Group 9. Today I'm going to present the methodology of our assignment. First of all is data collection. The type of the study is distributive in nature. It is quantitative research method and it is more focused on formulating research object, designing the method of collection of data, selection of the sample of data, processing and analysis to the data of collected, and finally reporting the results of the data collected. The data is collected through secondary data. It is collected from online database, and the sources of the data is referred and collected from datasets by P. Quarter and A. Morris with the title of data mining approach to predict forest fires using meteorological data. Method of data analysis. The method of data analysis is through observation method and data is analysis by statistical tool. We use Microsoft Excel to collect data, analyze and measure the data that we obtain. For the scale of measurements, most of the data is quantitative data and most of them is interval except the month, which is nominal. Table below show the scale of measurement of all variables in this study. FFMC represent the fine film moisture code, which is represent the field moisture of the forest litter fields under the scale of forest canopy. It ranges from 0 to 101 and the value of FFMC is roughly above 80. The DMC represent to dark moisture codes, which represent the field moisture of decomposed of organic bacteria underneath. It represents the moist condition of the equivalent of 15 days of 360 hours. DC represents the draft codes, which represent the drying dips into the soil. Temp represents the temperature of the research place, which is Montensinho Park. RH represents the relative humidity, which is a measure of how water vapor and water air mixture compare to the maximum amount possible. It is normally expressed in a percentage. A higher percentage of relative humidity means that water air mixture is more humid. Wind represents as a wind speed in Mountain Park, and it is measured in km per hour. Based on the Beaufort scales, the wind speed in Mountain Park is between 1 to 11 km per hour, which means that it is contain two wind speed, which is from between 1 to 5 km at light winds and also 6 to 11 km per hour at light breeze. Finally, months represent the month of the year that researchers doing research in Mountain Park. That's all from me. Thank you.
Our first objective is to investigate the time record when collecting data. Based on the table and the bar chart, we can notice that the highest frequency number of time record by FWI system is September with 34.67% or 52 times, meaning that time record data in September with FWI system is highest among other months in 1 year. The second highest frequency is 29.33% of 44 times, while the lowest time record by month is January, April, and June. It is represented with 0.67% or 1 time respectively. Our second objective is observe the weather data collected by weather observation. First is identify the temperature collected by month. Based on the table in the bar chart, we can see that the highest mean of temperature is 21 and the lowest mean of temperature is 5.3. The highest mean of temperature by month is June, which is 21, and the lowest mean of temperature by month is January, which is 5.3. Meanwhile, we can notice that July, August, and September have more stable average temperature in a month. This is because the mean of July, August, and September is 20.23, 18.98, and 20.55 respectively. Based on the table and the bar chart, we can see that the highest mean of wind is March, which is 4.79, and the lowest mean of wind is February, which is 2.83. The highest standard deviation of wind recorded by FWI system is October with 1.802591, while the lowest standard deviation is 1.231192. We can see that average speed of wind in March and August is higher than other months. It can represent by the mean of wind by 4.79 and 4.6 respectively. From the table and the bar chart, we can see that the range of the relative humidity in March, July, August, and September is more stable. It is represented by the mean, which is 40.29, 42, 44.29, and 41.15 respectively. The highest mean of relative humidity is January, shows 78, and the lowest mean of the relative humidity is October, shows 37.9. The range of highest and the lowest mean of relative humidity is 40.1.
My name is Koja Sheng. Now I'll continue to our presentation, which is objective 3 to identify index data recorded of fire weather Index FWI system by months. First, identify the five-fold motion called FFMC recorder by FWI system. In this bar chart, we can see the lowest mean of FFMC is in April, which is 63.5, and the highest is in September, which is 93.2712. The range between the higher and slower means of FFMC is 29.7712. This table shows the lowest standard deviation of FFMC is in February, which is 0.0408, and the highest is in August, which is 4.6120, and the range between the highest and lowest standard deviation of FFMC is 4.6120. Second, identify the draft motion called DMC recorded by FWI system. From this bar chart, we can see the lowest mean of DMC is in April, which is only 2.4, and the highest is 130.7827. The range between the highest and lowest mean of FFMC is 128.3827. In this table, we can see the lowest standard deviations is in February, which is 0.4930, and the highest is in August, which is 12.3205. The range between the standard deviation of DMC is 11.8275. Third, identify the drop called DC recorded by FWI system. From this bar chart, we can see the lowest mean of DC is in April, which is only 9.3, and the highest is in September, which is 702.1962. The range between highest and lowest mean of DC is 692.8962. From this table, we can see the lowest standard deviation of DC is in October, which is 2.5080, and the highest is in August, which is 102.9339. The range between highest and lowest is 100.4259. Fourth, identify the initial spread index ISI recorded by FWI system. From this bar chart, we can see the lowest means of ISI is in April, which is 0.7, and the highest is 13.5635. The range between the highest and lowest means of ISI is 12.8635. From this table, we can see the lowest standard deviations of ISI is in August, which is 0, and the highest is in September, which is 6.9161. The range between the highest and lower is 6.9161. A standard deviation of 0 means that a list of number is equal, and the number of ISI in July is 07, so that standard deviation is 0. This is all for me. Thank you very much.
In conclusion, in this research, the impact of meteorological factors on forest risks was investigated. The result we obtained is forest fires deal with climate conditions. The higher temperature, low relative humidity, and the lack of rain are the most favorable conditions for forest fires to occur. In a nutshell, based on the data analysis and result which my groupmate presented just now, we can conclude that the FWI system can give a big contribution to predict the forest fires. We hope that these FWI systems can help us to prevent forest fires happening. Based on the research above, FWI systems can predict the weather observations so that the related authorities can get the information such as fuel moisture costs and fire behavior indices. This can directly reduce the forest fires in future. So that's all from Group 9. Thank you so much.